Hello again, everyone. Welcome to our discussion of section 1.4, where we will talk about equations of lines such that these equations represent lines that are parallel to other lines or lines that are perpendicular to other lines. So before we discuss that topic, here is the steps that I'd like to briefly go over with you again. Please make sure that you spend half an hour to 45 minutes, maybe in this case, maybe 45 minutes, to read through the textbook section and on the same topic, 1.4, and attend the class or watch the video and take notes on anything that you think might be important to you or any questions that you might have as you watch the video or you watch the lecture in the class. And then, of course, look at the textbook and look at the lecture notes again, or look at the video and solve these problems that you saw the book and I solved without looking at our solutions. Solve them on your own, then check back with our solutions to see if in fact you are making progress and you're able to solve these problems on your own. And then complete all the homework assignments by the due date, and of course review all the previous material, because mathematics is cumulative, it builds on itself, so you need not forget the material we talked about in the earlier sections. Okay, so in the previous section, 1.3, we learned about the slope-intercept form of a linear equation, right? Which is that. We talked about that, we used it in our problem solving. Then another form of a linear equation, a linear equation basically has three different forms. Depending on what application you're applying it, depending on the context, you're going to use a different version of a linear equation. For example, if you're solving matrices, then linear equations have to be shown or ordered in a particular format that is different than the y equals mx plus b form or the slope-intercept form. It's the same equation, but it just the terms are arranged differently in that subject when you solve matrices. So there's another form of a linear equation. It's called the point-slope form, and it's that. So where does it come from? It simply comes from the slope formula with the y and x represented in the numerator and the denominator. So instead of y1 minus y2 or x1 minus x2, we have y minus y1, x minus x1. Makes no difference. But then if you cross multiply, as I've explained here, after cross multiplying, because the denominator of m here is 1, so 1 times 1 minus 1 is 1 minus y1. Right? 1 times y minus y1 is y minus y1. And then m times x minus x1 is m times x minus x1. So this whole point-slope form comes directly from the slope formula. Okay, so we're going to be talking about equations of lines that are parallel to each other, equations of lines that are perpendicular to each other. Now, for lines to be parallel to each other, a certain condition has to exist, and for two lines to be perpendicular, also a condition has to exist. So what is that condition? Suppose we have two lines that are parallel, right? Suppose we have that. Then that means that the slopes of those two lines must be equal to each other. So the critical piece of this definition is that for parallel lines, the slopes of the lines must be equal. Notice that before we know the slopes, that both lines are written in which form? Both lines are written in y equals mx plus b form. In other words, both lines are written in slope-intercept form. Once we have both lines written in that fashion, then we look at their slopes. If they're parallel, the slopes m1 and m2 must be equal. If they're not equal, then the lines are not parallel. Okay, then they must intersect. Okay. For perpendicular lines, the required condition for two lines to be perpendicular is simply that we begin with, once again, we begin with the both equations written in slope-intercept form. We make note of their slopes. And by the way, so perpendicular, I'm sure you know this from elementary geometry from high school, but if not, perpendicular means that the lines must make a 90-degree angle with each other, okay, when they're perpendicular. So, once we have both lines written in slope-intercept form, then we can conclude whether or not they're perpendicular if the product of their slopes equals -1. Okay? I don't know why every time I say this in my classes when people are present, there's always some people that say, is that the same thing as the slope of one line should be equal to negative reciprocal of the other slope? And I say yes. But for some reason, a lot of people like to remember this condition for two lines being perpendicular in this way rather than this way. I don't know why that is, but I've seen that a lot of people prefer to remember the condition like that. However you remember it, it's fine. But make sure that you remember the condition is either the product of the slopes m1 and m2 should be equal to -1, or the slope of one line is equal to the negative reciprocal of the other, slope of the other line. Okay, negative reciprocal of the slope of the other line. Okay, so in fact, this equation, if you know the slope of one line, to find the slope of the line that is perpendicular to this line, all you have to do is solve this equation for m2. Suppose you know that the slope of this line, some line, is 5, right? What would be the slope of the perpendicular line to that? It would be m2 equals -1/5, -1/5. Okay? So this equation can be used to find the slope of the perpendicular line. Okay, so moving forward here, here's the example, which means I have to give you the reminder that please pause the video, answer this question on your own on a scratch paper, then come back to the video. So given the graph of the line below, find the slope and y-intercept and write the equation of the line in slope-intercept form. Okay, so all we need to answer this question about slope and y-intercept is basically we need to find the equation of this line, right? So how do we find the equation of this line? Well, we're going to need the slope and y-intercept, exactly what they're asking us to find. But how do we find the slope and y-intercept? We just have a graph. Well, it's very easy, right? We pick 2 points. Any easy points on the line will do. I'll just pick the easiest points that are, in my opinion, the easiest one. So that one is 0, 4, and that one is -2, 0, right? I'm going to pick those 2 points to calculate the slope first. We can call these x1, y1 if you like, and x2, y2. So let's plug in into the slope formula here. y1 minus y2, that would be 0 minus 4. divided by x1 minus x2, that would be minus 2 minus 0, right? So that would be minus 4 divided by minus 2. Negative over negative is positive. 4 divided by 2 is positive 2. So that's the slope. They ask us to find the slope. We have this slope. Now, y-intercept? Well, we can make use of this equation that we just introduced. I'm sure a lot of you, if not all of you, have seen this before, right? The point-slope form. So we're going to make use of this formula, y minus y1 equals m times x minus x1, to find the intercept. And as a matter of fact, if you use this equation, you're going to find not only the y-intercept, but also the whole equation. So that's why it's a very useful tool, that one. So using y minus y1 equals m times x minus x1 with slope equals 2 and x, because we need x and y, right? Sorry, not x, y, but x1 and y1, with x1 comma y1 equals, let's take either one, minus 2 and comma 0, right? Minus 2. You can pick any of the points that are on the line. It doesn't have to be the intercepts, but I picked that one, minus 2 comma 0. Then let's plug into this formula with the quantities we have for this line, because again, that's a general line. That can be applied to any line. But for this specific line, we have this information that we should plug in. So we have y minus y1, which is 0, equals m, which is 2, times x, which is x, minus x1, which is minus 2. So minus minus 2. Okay? So y minus 0 is just y. M times, oops, sorry, I forgot to substitute for m. Let me correct that. So this m should have been 2 because we have that here. And this m should have been 2. Okay, 2 times x plus 2, right? So y, let's distribute. 2 times x is 2x, 2 times 2 is 4. So here's the equation of the line, and they ask us to find the slope. We did. They ask us to find the y-intercept. Right there. Y-intercept is clearly 0, comma 4, right? We could actually say that, have given them the answer right from the graph, but we can see it right there. So y-intercept is equal to 0, comma 4. You can either see it in the equation or the graph. And of course, they asked us to write the equation of the line in sloped intercept form, and that's what we have. So these 3 questions have been answered. Okay, so write a slope-intercept equation for a line with the given characteristics. Okay, so the slope is that, and the intercept is that. We know that the slope-intercept form is y equals mx plus b, right? Okay, so y is y. The slope m is minus 3/8. And the y-intercept is 0, comma 5. So plus 5, and we're done. That's it. Okay. Are you working ahead of me before watching the solutions? If you are, wonderful. Okay. So let's move forward. So there are 3 problems on this page, page 3. Those are the first 2, and that's the third one. Please make sure that you solve these before you see my solution. Okay, so the slope equals 0. Oh, wonderful. So that tells us that the line is horizontal, right? We've talked about this in the last video. And it passes through this point. If a line is horizontal and is passing through this point, then the equation of the line must be y equals the y value here. So the equation of this line is y equals 8. Because y equals 8, let me actually draw a little graph of this. So suppose we have like that, and suppose we have this point. Let's find this point. Where is it? Negative 2 comma 8. So negative 2 is here, and then 8 would be 1, 2, 3, 4, 5, 6, 7, 8. Negative 2, 8 would be that point. Okay, that is negative 2 comma 8. Right? So we have a horizontal line. How do we know that? The slope is 0. That is passing through that point. So let's draw a line right through it, a horizontal line right through that. Okay, like that. Okay, so that's the horizontal line with slope equals 0. That is passing through that point, negative 2 comma 8. Okay, so what would be the equation of that line? Well, y equals 8, right? Because x can be anything. It doesn't matter what x is. As long as y equals 8, that point, any point, is going to be on that line. If it's minus 100 comma 8, it's going to be here. If it's positive 1,000 comma 8, it'll be here. Because the y value is always equal to 8. So y equals 8 is the equation of that line. Okay. All right. So here again, we want to find the line that, oh, by the way, so do we need to know the y-intercept of this? For the line with the given... No, all they're asking is to write the equation in slope-intercept form, which is that. Okay, so they want us to write the equation for a line that goes through those, passes through these points, and they want us to write the line in slope-intercept form. Okay, so we begin with the slope, right? Again, I'm counting on you that you have already finished the solution for this. Okay, so slope is y1 minus y2 over x1 minus x2. This is x1 comma y1, x2 comma y2. Okay. So let's plug in. The slope is equal to y1, which is 7, minus y2, which is minus 5, divided by x1, which is minus 3, minus x2, which is minus 1, like that. So we have 7 minus 5, that's positive 5, minus 3, minus 1, that's positive 1. So we have 12 divided by negative 2 equals, that would be negative 6, right? Negative 6. So that's the slope. We're going to need that for our equation that we're finding ultimately. Now, let's make use of that point slope form of an equation that we learned on the first page. Whenever you're looking for the equation of a straight line, that's That, in my opinion, is more useful equation to use. You can also use the slope-intercept form, but this is much, in my view, it's much more efficient and useful. Okay, so using y minus y1 equals m times x minus x1, and the fact that slope is -6, and let's use any of these 2 points. It doesn't make any difference which one. You have to pick one though, -1 comma -5. So let's plug this information into this general form, because this is a general point slope form of an equation. We have specific information to plug in, right? So let's do that and find the line we're looking for. So we have, and by the way, so this is x1 comma y1, okay? So y is y minus y1. y1 is -5 equals m, which we found to be -6, times x is x minus x1, which is -1. Okay, so let's simplify. Minus minus 5 is plus 5 equals -6 times x minus minus 1. That is +1. Okay, so let's distribute. We have y plus 5 equals -6x. -6 times 1 is -6. Now let's move this 5 to the other side. It's positive on this side. When I move it, it's going to be negative. So y equals -6x minus 6 minus 5, right? We moved the +5 to the other side of the equality, and it changed the algebraic sign. So y equals -6x minus 11. There's the equation of the line that passes through those 2 points. Okay. I hope this answer agrees with the answer you have. And if it doesn't, you have questions, please let me know. So here is another couple of points. Again, please pause the video if you haven't already. Solve this problem. Find the equation of the line, then come back and compare your solution with my solution. Okay, so we have, once again, let's find the slope. I'm going to label these as x1 comma y1 and x2 comma y2. So the slope formula is y1 minus y2 over x1 minus x2. y1 is -3 minus y2, which is 0, divided by x1, which is 5, minus x2, which is 0. So we have -3 over 5 as the slope, right? So once again, using that equation, y minus y1 equals m times x minus x1, using this point slope form of a linear equation, and the fact that slope is, we just found, -3/5, and either one of those 2 points will do. I picked that one because it's easier, and that. Using that, so we have the general formula here, or the general equation in point slope form. Let's plug in here with our specific information, because we are looking for a specific line. Okay, so y is y, and let me label this. This is now x1 comma y1. Okay, so y minus y1, which is 0, equals m, which is -3/5, times x minus x1, which is 0. So y minus 0 is y, minus 3/5 times x. And this is our equation, written in slope-intercept form, of course, but the intercept here, the y-intercept, is missing because it is 0, right? It's at 0. I mean, I should. So it's the y-intercept is at 0, 0. Y-intercept is at 0, 0, like that. So that means this line is going through the origin. Any line that goes through the origin has its x and y intercept at the same location, which is the origin. Did we have another case like this? Let me see. Did we have another case like this? No, not on this, not on here. Okay. So here in this example or exercise, they're saying write the equations of the horizontal line and the vertical line that pass through the given point. Okay, so let's do that, but let me do this. I hope you pause the video and solve these two examples. And so in class, normally I give people some time. When I go over these worksheets in class, I normally say, okay guys, take a couple of minutes or 3 minutes or a minute, depending on the question, and answer this. And after a minute, then I'll write down my question for people to see. But here, you're at home or at the library watching this, and so I'll trust that you'll do that you solve these problems before you look at my solutions. But the way I want to answer this is first draw a little graph here. Right? And it says, let's plot this point. So minus 1/4, 7. So if we have 1, 2, 3, 4, 5, 6, 7, and minus 1/4, so if that's 1, minus 1/4 will be some point here. Right? Let me actually cover that. So that's some point there. And so that point is negative 1/4, 7, right? Write the equation of the horizontal line that is passing through that would be this, right? It would be a line. It would be writing the equation for a line that is doing that, right? Like that. So they want us to write the equation for that blue line that you see. Well, that's a horizontal line. The slope of it is equal to 0, and it's going through the y value for this point, 7. So the equation of that line is y equals 7. Okay. Now this one, let's find this point. Oh, they say also write the equations of the horizontal line and the vertical line. Okay, so all right, so let's do that. So that means if a vertical line is going through that point, it's going to have to look like this, right? Like that. So that is a vertical line going through that point. So this is the horizontal one. The equation of the horizontal line that goes through that, and the equation of the vertical line that is going through that. That line vertically is going through the x component of that point. But when you write the equation of that line, it has to be x equals negative 1/4. Okay? Because this is for the whole line. So the whole vertical line has that x value. Any point on that line has the same exact x value. The y values can be anything. It doesn't matter. But because all the points on that vertical line have a single x value, namely negative 1/4, that's going to be the equation of the vertical line. Okay. So this one, let's plot this point. That's a very tiny point. But still, I want to draw the graph because it gives you a visual representation, which is better than nothing, even though my graphs aren't that great with that point so large and things like that. But it's better than nothing. So here's another graph for this scenario. And let me take my increment a little bit large because, so I want to take 1, that's 1. So 0.03 would be somewhere here, right? And it's going to be 0.03 comma 0. So this is going to be the x-intercept, 0.03 comma 0. That's that point. Okay. So if you want to draw a horizontal line through that point, that's just the x-axis. We already have it, right? What's the equation of the x-axis? Do you know? Do you remember? Y equals 0. So y equals 0 is, oh, I should add here, that's the vertical line, equation of the vertical line for the previous example. Okay, so this one, this is the equation of the horizontal line, right? Y equals 0. That means if you're on this line, x-axis, the y value should be 0. It doesn't matter where you are. The y value for the infinitely many points that are on the x-axis, the y value for all of those points is 0 or R0, all of them. Okay. Now the vertical line would go through that point like this. Okay. So because it's going through that point, so all those points, all the points on that vertical line, all of them have the same x value. So x equals 0.03 is the equation of the vertical line. Okay? The horizontal line was just the x-axis, and the x-axis has that equation, y equals 0, right? If you're on the x-axis, the y value for all those points for the entire axis is equal to 0. Okay? And then that's the equation of the vertical line. So next example, they ask, find the linear function g, given that g is that and g at negative 1/4 is equal to negative 6, and g at 2 is equal to 3. And then they say once you find the linear function, then evaluate that function at negative 3. So please pause the video, answer this question, then come back to the video. And now I'm assuming that you've done that. Okay, great. So once again, they're telling us here, this information is telling us one point. That's one point. That's the coordinates of one point, and that gives us the coordinates of another point. In other words, that is the x value, this is the y value. That is the x value, that is the y value. Okay? So let's call this x1, comma y1, and that one x2, comma y2. For the sake of convenience, let me write them like this. So we have minus 1/4, comma negative 6, and 2, comma 3. Does it make sense? I hope it does. Okay, if not, I'm counting on you to let me know with your questions. Okay, so now that we have that and we're finding a linear function, so let's find the slope. That's the first thing we find, right? So m is equal to y1 minus y2 over x1 minus x2. So y1 is minus 6 minus y2, which is 3, right? Divided by x1, which is minus 1/4, minus x2, which is 2. Okay, so simplifying, we have minus 9 in the numerator. In the denominator, things are interesting, right? Because we have to take the common denominator. So the common denominator would be 1 for 2. The common denominator is 4. The common denominator is 4. And the 2, negative 2, has a denominator 1. So we need, the first fraction is happy. It's already got a 4 as the denominator, which is going to be this 4, which we will calculate. We're calculating right now what quantity should go here. But this fraction needs working, right? Because the denominator is 1, it's not equal to 4. So we need to multiply this one by 4. But we can't do this to the denominator and not do the same thing to the numerator. So let's multiply the numerator by 4 as well. Okay, so now let's find what these numbers are. So the first fraction is okay. It didn't get multiplied by anything. So the numerator is negative 1. The second, minus 2 times 4, 8, right? So then what do we have? We have minus 9 over minus 9 over 4, right? We have ourselves a complex fraction. We can't have that, right? We need to simplify this. So the denominator of the minus 9 here is 1, right? Earlier, I mentioned to you that the easiest way to simplify a complex fraction is this. Look at the farthest numbers numbers that are farthest away from each other. In this case, it would be negative 9 and 4. Multiply them and put them in the numerator. Then take a look at the numbers that are nearest each other, closest to each other. Multiply them and put them in the denominator. So multiply the farthest numbers, put them in the numerator. Multiply the nearest terms and put them in the denominator. All right? Now, negative 9 and negative 9 can cancel because they're being multiplied in the numerator and the denominator. As I was saying earlier in the previous video, if you had minus 9 plus 4, minus 9 minus 9, then you couldn't. So if you have this scenario, if you have minus 9 plus 4 divided by minus 9, you cannot say this and this. No, because minus 9 is being added, so this is not right. We can cancel because minus 9 is being multiplied by numerator and the denominator. Okay, so we end up with 4 over 1 or 4. So a slope is 4. Okay, now that we have this slope, now using y minus y1 equals m times x minus x1, using this formula, and the slope that is equal to 4, and any of those 2 points. I mean, when you look at them, which one is easier to work with? That one, right? So I'm going to pick that one. If you pick that one, you still end up with the same result, 2, 3. So now let's plug into this general equation so we can find the equation for the specific information we are given. Okay, so y and by the way, so this is our x1 comma y1, that one. So y minus y1 is y minus 3 equals m is 4, x is x, minus x1, which is 2. Okay, so y minus 3 equals, let's distribute the 4. 4 times x, 4x is 4x, minus 4 times 2 is minus 8. So y, let's move this negative 3 to the other side. It was negative on this side of the equality symbol, right? When we move it, it's going to change algebraic sign and become positive. So y equals 4x minus 8 plus 3 is minus 5. Like that. Okay? Is this making sense? We've done several examples, and if you have been taking my request and applying it and went through the solutions on your own before seeing my solutions, I am 100% sure by now you know exactly what to do. First you find the slope, then you use this equation, point-slope form, and some information that we have given, we are being calculating or given from the outset to find the equation of the line. I'm 100% sure if you've been doing that, you are very, very comfortable with this topic, which is my goal. Okay? All right. So here they say, in each case below, determine if the pair of lines is parallel, perpendicular, or neither. Okay, so we need to find the slopes of these and compare the slopes, right? If the slopes are equal, then the lines are parallel. If they're not equal, but if their product, if they're not equal, but if we multiply the slopes, the result is -1, then the lines are perpendicular. And if none of this is true, then it's neither. They're neither parallel nor perpendicular. Okay? All right, so both of these lines have been written in y equals mx plus b form. Okay? That's wonderful. So right away we know what the slopes are. So both lines, so note, both lines are in y equals mx plus b form. That's a good thing. That's why I'm asking you to notice it. Okay? Because right away we know what the slopes are. Right? m1, so m1 is equal to -3. m2, or the slope of the second line, is equal to -1/3. Are they equal? No. So these two lines are not parallel. If we multiply this by this, what do we get? Let's do that. m1 times m2 equals -3 times -1/3 equals +1, which is not equal to -1. So these two lines are neither parallel nor perpendicular. Okay? All right. So let's look at the next two lines. Note here both lines were in y equals mx plus b form, but here they're not in that form. So we need to put these lines in y equals mx plus b form. So note, put both lines in y equals mx plus b form. Okay? Let's do that, guys. So I'm counting on you having already done that. Okay. So doing that, so we have 2y equals minus 6 plus 5. And then divide both sides by 2, we get y equals minus 1/2 x plus 5/2. Right? How about this one? So we have 4y equals minus 2x plus 8. And then divide both sides by 4. We have y equals minus 1/2 x and plus 2. Right? Now, compare them together. Are the slopes equal? Yes, they are. So m1 is equal to minus 1/2. m2 is equal to minus 1/2. So m1 equals m2. Therefore, these lines are parallel. Okay, like that. All right, so these two lines, let's put them in. Oh, they're already in y equals mx plus b form, right? I mean, this one, it's in y equals mx plus b form, but the x comes later. So we can easily arrange it and say minus 6 plus 7, and that one is already there. So what is the slope of this line? m1 equals negative 1. What is the slope of this line? m2 equals 1, right? Coefficients of x tell us the slopes. So based on that, the m1 times m2 is equal to negative 1, right? That's m1, that's m2. So m1 times m2 minus 1 times 1 is minus 1. So these lines are perpendicular. Okay. Do these conclusions agree with your conclusion? If they do agree, that's what I'm looking for. Okay, wonderful. Okay, all right. So the next question, it says, given this equation or function, find lines that are parallel and perpendicular to this function, and while the parallel and perpendicular lines pass through that point. People ask me sometimes, why do we need that point? Well, we need that point because you take any line, that one, for example, right? That one. You draw that line, then there are infinitely many lines that can be drawn that are parallel to that line. By the same token, you can draw infinitely many lines that are perpendicular to that line. So which one is it that you're looking for? You have to specify which line. How do you specify? Well, you specify a point. Because out of those infinitely many lines that could be parallel or perpendicular to this line, only one of each, one of the parallel lines and one of the perpendicular lines, can go through that point. Okay, we're looking for that parallel line. We're looking for that particular perpendicular line. So that point is critical. If they don't give us this point, we are looking for infinitely many lines then. It's not possible, right? So we're looking for a specific line that is parallel and a specific line that is perpendicular with that point. Okay, so the first thing we establish is, what is the slope of this line? And it's already in y equals mx plus b form, so m1 is equal to 2. That's the slope of that line, right? So for the parallel line, for the parallel line, M2 must be equal to 2, right? Two lines are parallel if their slopes are equal. So we know that. Now, using this formula that we saw on the first page, y minus y1 equals m times x minus x1, using this formula and the fact that m2 is equal to 2, or the slope is equal to 2, and that point that we were given, and that this parallel line must go through that point, we can find the equation of the parallel line. All right, so let's do that. We're going to plug in. So this is our x1 comma y1, that one. Oops. So we have y minus y1, y1 is 6, equals m is m2, the slope of this line, which should be equal to the other one because they're parallel. So 2 times x minus x1, which is minus 1. So let's simplify. We have 2 times x plus 1, right? Minus 1 is x plus 1. Then let's distribute the right-hand side. So we have y minus x equals 2 times x is 2x, 2 times 1 is 2. Right? Like that. And then let's move the negative 6 to the other side. When we move it, it changes algebraic sign to its opposite, which is positive. So y equals 2x plus 2 plus 6. So then y equals 2x plus 8. So this line is parallel to that line, and it goes through this point. Okay? So let's find the perpendicular line. For the perpendicular line, we know that that original line has that slope, right? That's the slope of that line. We know that. So, for perpendicular lines, m1 times m2 must be equal to minus 1. That's the condition for perpendicular lines, right? So let's plug in and solve for m2. I mean, you can readily see m2 should be minus 1/2, right? Because minus 1/2 times 2 is negative 1. But if you don't see it right away, just plug in. So m1 is 2, m2 we're looking for, and the other side is minus 1, right? So solve this for m2. m2 is equal to, divide both sides by 2, minus 1/2. Okay? So now, so that's the slope of the perpendicular line. Now, using y minus y1 equals m times x minus x1, and the fact that m2 is equal to minus 1/2, and the fact that the perpendicular line must go through this point, we can start plugging this specific information into this general formula we have. And so once again, this is x1 comma y1, right? So y is y minus y1, which is 6, equals m, which is minus 1/2, times x minus x1, which is minus 1, like that. So let's simplify the right-hand side. We have minus 1/2 times x plus 1, right? Let's distribute the minus 1/2 into that. We have minus 1/2 x, minus 1/2 times 1, minus 1/2. Then let's move this negative 6 to the other side. Y equals minus 1/2 x minus 1/2. Moving the negative 6 to the other side makes it positive 6. So take a look at these. We need a common denominator to be able to add these two constants, right? We know that the denominator of 6 is 1. What is the common denominator? Common denominator is 2. So the first fraction minus 1/2 is happy because it's got the common denominator equal to 2, right? It's got its denominator equal to the common denominator 2. So we don't need to do anything to this fraction. But how about this one? Well, we need to make this 1, 2. How are we going to do that? We're going to multiply the denominator by 2. But we can't do this to the denominator and not do the same thing to the numerator. So we're going to multiply the numerator by 2 as well. So what do we have? We have y equals minus 1/2 x. Now, these two fractions add up to, let's see what the numerator adds up to be. The denominator is 2, we know that. Here we have minus 1 plus 6 times 12. So 6 times 2 is 12. Minus 1 is positive 11. So plus 11 over 2. Okay? And that is our equation of the perpendicular line. So this line, let me see if I can put everything on the screen. Yes, barely. So this line is perpendicular to this line up here. To this line up here, and it goes through this point. This line here at the bottom of the screen is perpendicular to this line, and it passes through this point. Okay? I hope it's making sense. All right. If you're getting these solutions ahead of me and your solutions are agreeing with this, it's really wonderful. You're making great progress through this semester. Okay? But of course, if you're not doing it, then I'm not going to know until the exam time. The exam time, then I'll know if you've been doing this or not. And I hope you all get an A on the upcoming exams. Okay. So, given this equation, find lines that are parallel and perpendicular to this function while the parallel and perpendicular lines pass through this point. So, this is exactly like the other problem, except that here we have a different equation and we have a different point, right? And this equation is not being given to us in y equals mx plus b form yet, but it's not far away from it. We can easily put it in that form, right? So put 2x plus y equals minus 4 in y equals mx plus b form. Okay, in this form. Let's do it. So that would be y equals, move the 2x to the other side, minus 2x. It was positive. When you move it, it becomes minus 2x, minus 4. Okay? So here it is. Okay? There we have it. Now, what is the slope of this line? It is, so m1, let's call it m1, is equal to minus 2. Okay? So, for the parallel line, we have the slope of the parallel line should be equal to that, right? For the parallel lines, we must have m1 equals m2. Therefore, m2 must be equal to minus 2. That's the slope of the parallel line that we're looking for, right? Okay, so now using that formula, point slope form, which we have on the first page, y minus y1 equals m times x minus x1, using that, and the fact that m2 is equal to negative 2, and the fact that the parallel line must go through that point, right? Minus 4 comma minus 5, and remember that this is x1 comma y1 in that formula, right? Okay, so now we can plug in y minus y1, which is minus 5, equals m, which is negative 2, times x minus x1, which is minus 4. So let's simplify. Minus minus 5 is positive 5, minus 2 times x minus minus 4, that's x plus 4. Before moving this 5 to the other side, let's simplify. Let's distribute this negative 2. Okay, so y plus 5 equals minus 2x, minus 2 times x, minus 2x, minus 2 times 4, minus 8. Now let's move the 5 to the other side. It's positive on the left. When we move it to the right, it becomes negative. So y equals minus 2x minus 8 minus 5. Okay, I'm trying to keep everything on the screen. That's why I'm not scrolling up the paper. I hope this is okay with you guys. So now we have y equals minus 2x minus 13. And that is the equation of the parallel line. Okay, so this equation is parallel to that equation, that one, and it passes through this point. Okay, that's the idea. So let's find the perpendicular line. For the perpendicular line, like that. So we already know the slope of the original line. The slope of that line is m1 equals minus 2. So the condition for two lines to be perpendicular is this. m1 times m2 should be equal to negative 1. Right? That's for perpendicular lines. So that's for the parallel lines, we have that. For perpendicular lines, we have that. Okay, so let's plug. You should know right away that the m2, I mean, some of you, if not all of you, I'm sure you're seeing that m2 should be 1/2, right? But if not, you can plug it in and calculate it. So for m1, plug in with negative 2 times m2 equals minus 1, right? Now solve for m2. m2 is equal to minus 1 over minus 2. Minus divided by minus is positive. So m2 equals 1/2. Okay? So we have our slope of the perpendicular line. So now using y minus y1 equals m times x minus x1, and m2 equals 1/2, and the fact that the perpendicular line goes through this point, let's find the equation of the perpendicular line. So we have y minus y1, which is minus 5, equals m2, which is 1/2, times x minus x1, which is minus 4. Right? Like that. And then let's simplify. Minus minus 5, that's positive 5. 1/2 times x minus minus 4, that's positive 4. Now let's distribute this 1/2. Y plus 5 equals 1/2 times x is 1/2 x. 1/2 times 4, that's 4 over 2, which is 2. So let's move this to the other side. We have y equals 1/2 x plus 2 minus 5, right? And so here we have y equals 1/2 x, 2 minus 5, minus 3. Like that. So what we've been able to find is this equation is perpendicular to this equation, and it passes through that point. Okay? All right. So the next question, it says, determine whether each of the following statements is true or false. It says, these two lines are perpendicular to each other. Is that true? Well, the slope of this line, and note that both of them are in y equals mx plus b form, right? So we can quickly see their slopes, or we can compare their slopes immediately. 2 and negative 2 are not equal, and they don't if you multiply this by this, you get minus 4, not negative 1, right? So 2 times negative 2 is equal to negative 4, not equal to negative 1, so therefore false. This statement is false. The lines x equals minus 3 and y equals 5 are perpendicular. This is for sure true, right? For sure true. Why? This is a vertical line, and this is a horizontal line. So any vertical and horizontal line, they're going to be perpendicular to each other, right? So true. The lines this and this are parallel. Well, we know the slope of this line is 2/5, right? Let's find the slope of this line. It's not, I mean, some of you, if not all of you, can see that it's 2/5, but I'd rather suggest that please rewrite, make sure that both equations are in y equals mx plus b form, or in slope-intercept form. So let me put that in this equation in that form. Y equals 2/5 x plus 4, right? When you move this to the other side, it becomes positive. So compare the slopes. So m1 is equal to 2/5, m2 equals 2/5. Therefore, m1 equals m2. So this is a true statement. True. Okay. It says the line and this are perpendicular. Let's see. We got to put neither one is in y equals mx plus b form, right? Neither one is in slope-intercept form. So let's put each one in slope-intercept form. So we have 3y equals, move the 2x to the other side, It is positive on the left. When you move it to the right, it becomes minus 2x plus 4. Divide both sides by 3, right? So y equals minus 2/3 x plus 4/3. That's the slope-intercept form for this equation. Let's do the same thing here. So minus 2y equals 3x, move it to the right. When you do that, it changes algebraic sign. It's now positive. When you move it, it becomes negative 3x plus 4. Let's divide both sides by negative 2. We have y equals minus 3 divided by minus 2. That's minus divided by minus is positive. 3 over 2x. 4 divided by minus 2, that's minus 2. So then if these two lines are perpendicular, then the slope of this line is m1 equals minus 2/3. The slope of this line, let's call it m2, is equal to 3/2. Right? So m1 times m2 equals minus 2/3 times 3 positive 3/2. That's equal to minus 1. So this is true again. The lines are in fact perpendicular because when you take the product of their slopes, it's equal to minus 1. Okay? We have come to the conclusion of another lesson here. I'm hoping that you are, as usual, you are working through these problems ahead of me in the video. And so I'm hoping for that. And for now, have a nice day. Until next time, I'll see you all again.